You've been told a clean and comfortable version of history. A version in which the 19th century was a time of coal smoke, horse carts, and slow, gradual progress. A time when engineers supposedly worked with slide rules by candlelight, and armies of factory workers used primitive tools to create the earliest metal giants of the industrial world. But once you inspect the details, even briefly, the official story begins to look less like history and more like a carefully rehearsed myth. Our investigation begins with one simple question: where did all the metal come from? Historians claim that tens of thousands of tons of iron and steel were produced, transported, shaped, and assembled using technologies that were barely out of their infancy. But numbers don't lie. And the numbers behind two of Europe's most famous structures, the Crystal Palace in London and the Eiffel Tower in Paris, reveal a technological and industrial contradiction so massive that it challenges the foundations of everything we're told about the 19th century. Take the Crystal Palace, for example. Officially completed in 1851, it was a structure so large that even today, modern architects still marvel at its scale. A building made almost entirely of cast iron and glass, stretching over 90,000 square meters in area. It wasn't a small exhibition hall. It was a metal and glass continent, assembled in just a few months. And the textbooks say it was designed by a gardener, Joseph Paxton, a man known for building greenhouses, not mega-industrial complexes. This man, without the tools of modern engineering, without advanced mathematics, without modern metallurgy, supposedly created a structure that required 4,500 tons of cast iron and hundreds of thousands of panes of glass. The scale alone should make any rational person pause. Metallurgy in the mid-19th century was still struggling with quality control, consistency, and volume. Yet we are told that nearly every iron piece of the Crystal Palace was produced rapidly, shipped rapidly, and assembled rapidly, all without major delays, accidents, or design failures. According to historical production data, British ironworks in 1851 were already stretched thin, supplying railroads, machinery, weapons, and expanding urban infrastructure. To divert thousands of tons of iron for a temporary exhibition structure would have required a national industrial sacrifice. Yet not a single record suggests that other industries slowed down or suffered shortages. It's almost as if the metal didn't need to be produced at all, as if it was already available, already stockpiled, already prepared in massive quantities. And that leads us to an even stranger question. How was all this material delivered? Imagine the London of the 1850s. Narrow roads, muddy paths, no modern trucking, minimal rail coverage, and horse carts as the primary transport vehicles. Moving thousands of tons of iron beams should have brought the city to a standstill. Streets should have been clogged day and night. Newspapers should have reported chaos. City officials should have complained endlessly about the disruption. But there is silence. A silence that's louder than any explanation. It's as if the material simply appeared on site, ready to be assembled. Now travel forward a few decades to Paris in 1889, the year the Eiffel Tower was completed. The official story claims that this 300-meter iron giant was built in just 2 years, 2 months, and 5 days. The structure weighs 7,300 tons, Not steel, not the metal of the modern era, but puddled iron, a material produced by manually stirring molten metal with long rods in a furnace. In other words, a process dependent on physical strength, unpredictable temperatures, and inconsistent chemistry. Yet, the Eiffel Tower consists of 18,038 individually crafted parts, assembled with 2.5 million rivets, all perfectly aligned, fitting together with a precision that modern engineers still admire. But puddled iron is inconsistent by nature. Each batch varies in strength, carbon content, and durability. How then did thousands of irregular parts behave like a modern, standardized puzzle? The official explanation requires us to believe that multiple factories, each using different tools, different measurements, and different quality standards, produced perfectly interchangeable components on the first try. No mismatches, no reworks, no delays, and somehow no public record of massive logistical challenges in transporting 7,000 tons of iron through the crowded streets of Paris. This is the first crack in the official narrative, because once you begin questioning the origin of the metal, the speed of its production, the logistics of its transport, and the precision of its assembly, you discover that the history of these structures reads less like engineering and more like impossibility. As if these buildings weren't the result of the technologies of their time, but relics of a capability that had already existed, one that official history simply doesn't talk about. If the production and delivery of the metal already strained the limits of 19th century technology, the assembly of these structures pushes the story into outright fantasy. Because producing thousands of tons of iron is one thing, assembling them with near-perfect precision using hand tools, paper drawings, and guesswork is something else entirely. Look at the Eiffel Tower. Every one of its 18,038 parts had to be drilled, shaped, and measured before arriving on site. According to the official version, all the holes for all 2.5 million rivets were drilled in advance at different workshops scattered throughout France. There was no standardized system of measurement, no uniform industrial equipment, no shared calibration. Every factory had its own tools and its own inch. Even millimeters weren't consistently defined. Under such conditions, compatibility should have been nearly impossible. And yet, the tower assembled flawlessly. The pieces aligned without major reworking. There were no large-scale redesigns, no massive corrections. It rose with an uncanny smoothness, as though it had been prefabricated at a single advanced facility capable of precision we barely achieve today. But such a facility doesn't exist in the records of 19th century France. The Crystal Palace presents the same contradiction. Thousands of unique iron castings, each requiring detailed molds and exact consistency, were delivered ready to use, without reports of misfits or rework. Even today, large metal assemblies require on-site grinding, resizing, and constant adjustments. But the Crystal Palace, allegedly built using mid-Victorian tools, went up almost effortlessly in just a few months. And then there's the silence from the sources of the time. No newspapers describing endless delays, no public complaints about noise, failures, or supply issues. For structures of this scale, problems should have dominated the headlines, but instead the record reads as if everything was strangely easy. This leads to a disturbing pattern. Both structures behaved like pre-designed kits, as if their builders weren't inventing or experimenting, but reassembling something they already understood extremely well, something possibly inherited, reused, or repurposed. But the story becomes even stranger when you consider the fate of the Crystal Palace. In 1936, it burned down in a fire so intense that iron beams bent and twisted as though exposed to an industrial furnace. Cast iron doesn't burn. Glass doesn't ignite. For thousands of tons of metal to deform, Temperatures would need to exceed what a simple building fire can produce. Yet the official explanation insists it was a routine accident. If the palace truly belonged to the Victorian era, the fire makes little sense. But if it was a relic of a technology more advanced than the era that inherited it, then its destruction becomes far more suspicious. Perhaps it was removed not because it failed, but because it revealed too much. A glimpse of a capability the official story can't explain. When you place all these contradictions together, the impossible metal production, the silent logistics, the flawless assembly, and the mysterious destruction, a single conclusion begins to emerge. These structures do not behave like inventions of their time. They behave like remnants. Objects created with technologies far beyond what the 19th century officially possessed, then attributed backward to craftsmen who simply could not have executed such feats under the conditions described. Consider the Eiffel Tower again. To this day, engineers marvel at its precision. Its curves and load distribution follow patterns that resemble modern finite element modeling, something developed a century later. The official narrative says these calculations were done by hand, with slide rules, candles, and intuition. But the margin of error tolerated in such a project is microscopic. A misalignment of even a few millimeters would have cascaded into structural failure. And yet the tower shows no evidence of trial and error construction. It stands as if designed and produced by a single advanced system, one that had mastered metal forming, stress analysis, and mass standardization. The Crystal Palace is no different. Its scale and rapid assembly resemble modular construction, the kind used today with factory-built components. But Victorian foundries were inconsistent, slow, and prone to error. Glass production was delicate and wasteful. Transport was unreliable. Despite all this, the palace supposedly rose in mere months with nearly perfect uniformity, at a time when even small projects suffered constant delays. It doesn't match the industrial capability of the era. It surpasses it. And then there is the absence of struggle. Great engineering projects always generate noise, political fights, technical issues, public criticism, budget overruns. But these two megastructures, almost nothing. No chaos, no panic, no "how do we do this" arguments. Instead, the records read like the construction of ordinary buildings, as if the builders were assembling something already fully planned, fully surveyed, and fully understood. So the question becomes unavoidable. Where did this knowledge come from? How did societies that relied on horse-drawn carts suddenly produce metal structures that modern engineers still study with disbelief? How did workers with basic tools achieve accuracy that challenges today's equipment? And why do the archives gloss over the most difficult parts of the story? The logistics, the failures, the technical limitations, the physical impossibilities. The simplest explanation is also the most unsettling. These structures may not have been original creations of the era. They may have been built using knowledge, methods, or resources inherited from a source we no longer acknowledge. Whether that means a forgotten industrial capability, a lost technology, or an earlier advanced culture is open to debate. But what is clear is that the traditional story does not add up. The numbers don't align, the physics doesn't cooperate, and the timeline strains belief. When you examine the Eiffel Tower and the Crystal Palace with modern eyes, you do not see miracles of ingenuity. You see anomalies, monuments that do not fit the decade, the tools, or the capabilities claimed to have built them.
They stand like warnings carved in iron and glass, reminders that history may be missing a chapter where technology was not primitive but sophisticated, where construction was not guesswork but precision, and where the world possessed knowledge we have only begun to rediscover. The question now is not whether the official story is incomplete. The real question is, what else have we inherited without knowing it?